Okay, so before we get started on this video, here's a couple of things I need you to do, and then you need to pause it. I need you to actually read through example 1 so that I don't spend 5 minutes reading it to you. And then I need you to put the data for row B and row A into StatCrunch. So pause the video, read the prompt, pop these numbers into StatCrunch so that you can play along with me. Okay. Awesome. Now that you've done that, we need to talk about what's going on. In 8.3, we are doing testing for 2 samples, just like we did in 8.1 and 8.2. The difference is we're going to have a dependent sample this time. So it's also known as matched pairs testing. And what we're going to do for every pair of data is find the difference between them. So we're creating a new variable called the mean difference. So our problem has a before and an after for 10 different districts. So I've already done the first one for us. 10.3 minus 9.1 is 1.2. 7.2 minus 8.4 is negative 1.2. 2.9, and so forth. This is not hard to do, but if you had a lot of data, it would be easier to do in StatCrunch. So I do have that pulled up. I have before and I have after. Pause the video at any time that you need to so that you can catch up to me. But before and after, I'm coming into this third column. It doesn't matter where. I'm just clicking on a cell. I'm going to go to Data, Compute, Expression. What I want to do is build an expression that takes before minus after. And I'm getting it to come up by just double clicking on it. Now, let's see, if I hit OK and tell it to compute, it doesn't put it where I'd like for it to, but I now have a before minus after column. And what I need from that is what is the average difference. So we can do that in StatCrunch by clicking on Stat, going to Summary Stats, going to Columns, and choosing the column we want the statistics on. So once we've done that, we come in and we click on Compute, and we need the information that we see on the screen. We need the mean is 4.5, and the standard deviation is 4.1226. So I'm going to come back into my notes and write myself a note that the average difference from the sample is 4.5. The standard deviation from the sample was, what did I say? I already forgot it. I hate when I forget stuff. Don't get old. 4.1226. Is that what I said? Awesome. So, what else do I know in this problem? I have an alpha level of 5%, and I'm going to look at that the mean difference is actually 0, okay? It's clearly not 0 because the sample is 4.5, but the question is, statistically speaking, is the 4.5 far enough away from 0 that we could actually say there's a difference? So as we go through and we read this problem, we can I personally think that the ho should always just be that the mean difference is 0. And then the ha has to do with what you're talking about. So the mean difference in our case is greater than 0, right? Because we had 4.5. So then the book says, well, I can't do equal to here. I need to do less than or equal to for the ho. And I don't know that I really like that. So this is the claim from where? From the district. How'd they word it? From the highway department. And this is what we're interested in. Well, we choose T. Why? And it's less than 30. Sigma is unknown. Blah, blah, blah. T is found by taking the sample mean minus the population mean divided by the standard deviation divided by the square root of n. So you've done this portion of the test already, and chapter 7, actually. So I do a little number crunching, and I should get that t is 3.4518. The degrees of freedom is 9, because I had 10 districts. And now I need a p-value statement. The p-value statement will read like this, that it's the probability that t is greater than 3.4518. And I can get this from my table, but I'm going to use StatCrunch. You could use your calculator. So let me show you. In StatCrunch, again, you have calculators under statistics. Maybe. I'm having so many difficulties with my technology tonight. Hold please. Okay, so apparently I have a virus, so I cannot show you. So, you would go into StatCrunch and click on Calculate. You would tell it greater than and give it the degrees of freedom. So I'm hoping you know how to do this part at this point, because I cannot show it to you. Oh, I'm so aggravated. But you should get something from your technology that's about 0036-ish. Now that's super small. So that's saying the probability of having an average difference of 4.5, if the average difference really is nothing, is so incredibly small. So we come back to the null and we say, you know what, we're going to throw you away because the p-value is way too small. And we're going to say we have evidence to believe that there is an actual difference. Okay? So I don't think you'll find this chapter hard. I don't know that there's any point in me running any more tests with you because they're all the same. And I can't show you the technology. So that really stinks. So what I will do is post example 2 and example 3 written up for you. You just won't get to hear my voice. I'm really sorry. But apparently I have a virus on my tablet. And I can't open... I don't know what happened, but I can't open things. I open it and then it freezes. Okay, well, so a final wrap-up to this is you have to come up with the average difference and the standard deviation for the average difference. And then you run this like it's a one sample test. So here was my sample mean. This is always going to be the population mean. And then divide by the standard deviation and the square root of n. Okay, have a great day. Sorry about all that.